Welcome to EDU World Space.
In this question, electrons are accelerated by potential difference of 2850 electron volt, and we have to find the maximum possible resolution of the microscope. So basically, we have to find the wavelength of the electrons. Now, we see that uh, the potential difference is basically equal to the change in kinetic energy. Now, assuming the electrons start from rest, the initial kinetic energy will just be equal to zero. So, this value will be then equal to the final kinetic energy. I'm just writing Ke with no subscript for simplicity, and the kinetic energy, this is equal to P square over 2m. Now, we see that this is small enough compared to the rest mass energy of the electron. This means that the electron is non-relativistic, and that's the reason we wrote the kinetic energy as p square over 2m. Now, using equation 27 8, we write that the wavelength is equal to h over p, which is equal to h over 2 times mass, kinetic energy, and a whole root over. Now, we see that the value of h is in joules and the kinetic energy is in electron volt. So we have to make some manipulation to get the numerator and the denominator of the same unit. You can either convert the kinetic energy into joules and use the value of Planck constant here, or you can convert this, the numerator, into electron volt and uh, and do the rest of the calculation. So for me, I know the value of HC from previous problems. As you can see that if you have been following the previous problems, you will see that in problem 29, we are actually calculating the value of HC, and we get this value to be 1240 electron volt times nanometer. So to use this value in this equation, I'll multiply C in both numerator and denominator. But since there is a root over here, and so when the C goes in, it becomes C square. So yeah. And there is one more thing that we know. We know that mc square, or the rest mass energy of the electron, is 0.5. Okay, I might not have enough space. Okay, so maybe now I can write. So the rest mass energy of an electron, or mc square, is 0.511 mega electron volt. And this value is basically what we have here. So now we have everything expressed in terms of electron volt and nanometers or meter. So yeah, let's do the calculation. Let's plug in all these values in this equation now. So Hc is 1240 electron volt times nanometer over 2 times mc square, which is 0.511 times 10 to the power 6 meter. Sorry, 10 to the power 6 electron volt. Make sure to convert your units from mega to the standard one, times 2850 electron volt. And we have a root over. So we get this value to be 23.30 times 10 to the power minus 11 meter, or you can simply write this to be 23.0 picometer. So this is the value of this is the maximum resolution the electron can have.